This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
God, I love that new music. Welcome back into Viterbi Voices. This is episode
121.
121. Thank you so much for joining us. As usual, I'm one of your co-hosts. My name is Paul Ledesma, Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And my name is Audrey Roberts. I'm a junior studying mechanical engineering here at USC.
So with episode 121, what is our topic today?
Yeah, this is a really fun episode. I talked to Camila, who is one of our seniors studying civil engineering with an emphasis in building science. And we talked about her summer. So she was in New York City working for Arup, doing environmental consulting and sustainability consulting.
Cool.
It was super cool just to hear about building science too. It's an incredible major. They're doing a lot of really awesome stuff.
That's awesome. So new for season 5, what we're going to do is we're not going to make really long intros like we used to have before, and we used to have big discussions to catch up. We're just going to cut straight into the episode, but stick around toward the end of this conversation where Audrey and I will catch up with each other, find out what's going on, and also give you some relevant updates related to admission, the university, and what's happening this week at USC. So enjoy the episode. We'll see you on the other side.
Welcome, Camila. Today we are with one of our seniors. Can you introduce yourself?
Oh my god, I can't believe it's senior year.
Yeah.
But yeah, I'm Camila. I'm a senior studying civil engineering with an emphasis in building science. I'm originally from Colombia, but I grew up in Miami, Florida. And I guess that's a little bit about me.
Yeah, that's great. Well, I'm so excited to have you here today because I'm obsessed with your major, and this
I am too.
It's so cool. So maybe first, can you talk a little bit about what civil engineering is at USC, and then kind of how you're emphasizing in building science and what that means?
Yeah, great. So civil engineering at USC is definitely a smaller major, and it has kind of a smaller major feel. So all of our classes are around 30 people, like the graduating class is around 30 people. And that really allows us to have really cool relationships with each other. Like, we're all very close together. We'll study together. We'll have different activities together, and just, like, because we're so close-knit and, like, get to know each other very well in classes. But basically, there's a general civil engineering education, which you can just do a general civil engineering track, where you have all of your foundational design classes like concrete design, steel design, introduction to structural engineering. You'll learn timber design and just how different structural systems within a building come together, the different codes that you have to follow, and different kind of best practices, because you can just follow a code and design a building that's like meeting all these code requirements, but that's not always the best practice. Right. So you'll have design classes based around that where you learn different softwares too, like structural analysis softwares. You learn architectural design softwares like Revit. And yeah, I think that that's kind of a base. And of course you have like your general statics, dynamics, fluid mechanics. You have to take general physics classes. It seems like that was so far away ago because it's senior year. So now all of my classes are a little more specific, and it's more of those design classes versus like the basic physics, chemistry, math, differential equations. Like, you have all of that at the beginning, and I like forget about that sometimes because like it feels like it was so long ago, but really it was only 3 years ago.
That's crazy. It is.
And then within civil engineering, I think there's 5 different emphases that you can take. Mine specifically is building science, so it's really cool because it's combined with the architecture school. So I would say around a third of your classes are in the architecture school. Awesome. You have one studio every semester starting your sophomore year, and you have some architecture or history classes as well. So it's really cool because it kind of balances out the very code-driven, math-driven, civil engineering, structural analysis work with more design-oriented, thinking about sequencing through a building, how an occupant will walk through it, what it feels like to actually design for kind of more human-centered design versus like building performance design, if that makes sense.
Right. That's so cool. Oh my goodness. And what a good opportunity to be a part of the USC Architecture School as well, because they have a 5-year program, which is kind of unique.
Yeah.
So,
and it's pretty cool because I actually have a lot of friends that are also in their architecture school, so we collaborate with them a lot sometimes. And sometimes I'll just like pop into their studio as well, and they might have a question of how do I like make my model stand up, and you as like a civil engineering major like can help them figure that out, which is like so silly because like it really does imitate real life.
Yeah.
But it's a lot of fun. I like really enjoy the major. There's only 7 people in my studio and it's all civil engineers. So you have a specific building science studio.
Okay.
And you'll be with those people throughout those 3 years, like 6 semesters of studio classes.
Okay. Amazing. And then, so this summer you were in New York, right? Working at Arup. Do you want to talk a little bit about that?
So I was in New York City. I was working for Arup. It's a multidisciplinary engineering and consulting firm. So they do anything that you could think of in the built environment. They do like rail, any sort of building design, any sort of like city planning is also a big part of what they do. So the cool thing and what drew me to Arup in the first place is that they have a really strong philosophy of only taking on projects that are environmentally and socially responsible. Okay. So they don't do any like commercial buildings like a mall or like a big casino or anything like that. It'll all be like museums or like low-income housing or a building that'll become like an icon for the city. So it's all of the projects are super interesting.
Yeah.
Which is, and have some sort of basis behind kind of the meaning behind them, not just profit driven, but also like they're going to make a cultural center for the city, or they're going to create spaces where people's lives are enhanced versus just like somewhere that they can spend money.
Right. Which is so important, especially in a city like LA where there's so many people, and having a really cool space like the Broad or something
exactly.
like that.
So the Broad actually, Arup was an engineer behind it. I think they did primarily the lighting design.
It's so good.
Yeah. So the cool thing about the lighting in the Broad that Arup engineers kind of emphasized and were like focused on designing for, since the Broad is an art museum, you can't have direct natural light hitting the art pieces. So they had to design, if you look at kind of the ceiling while you're walking through the space, you get a lot of natural light into the building, but it's not direct natural light. So the like openings and the windows and the skylights to that open up and bring in natural light are slanted in a way that the natural light reflects off of a white surface before it enters the building. So everything is like very calculated and meticulous and like designed in a way that really helps the building perform in the way that it's supposed to. But I wasn't doing lighting design. So specifically,
would a civil engineer be doing lighting design? Like, is that
they can?
Okay, just something.
It's interesting because I feel like the teams there are very interdisciplinary within themselves. So like within lighting design, you'll have someone that studied mechanical engineering, you'll have somebody that studied architecture, you'll have somebody that like was an electrical engineer. So like even within, of course, like when you're working on a project, there's like different teams within Arup will be working on the same project, but even within each specific team, like lighting, for example, it's very interdisciplinary.
Okay.
Like people come from all these different backgrounds. And that was the case on my team as well. So I was on the sustainability consulting team, and we had people that had architecture backgrounds. We had a mechanical engineer. people with masters in sustainable development, people with masters in wastewater management. So it was very diverse backgrounds that all come together, because you don't really study sustainability as a career, you know, like there isn't like a sustainability, I guess there's sustainability science classes and there's like similar majors, but I think it's so embedded in everything that we do and everything that we learn in all of these different majors that people come from so many different backgrounds and work in it. But it was really cool because it wasn't really things that I had seen so much in my classes, because it's very more structural focused, I would say, in my classes. This was a lot of like energy analysis, climate analysis, thinking about the future of climate change and how can we better choose the systems that go into the buildings that can adapt and that can like provide the occupant comfort that we need for the current climate and also future climate.
Cool. So what's an example of like some sort of system that
so for example, when you're looking at a building, there's so many ways that you can provide heat and cooling, depending on where you are and what resources you have around you. So doing different feasibility analysis for the building of like, okay, do we use ground source heat pumps as our form of heat? Do we use solar energy as our form of heat? If like these things aren't sufficient, what's the cleanest way that we can get energy to meet the demand of the building? But that starts obviously first with like trying to reduce the amount of mechanical equipment that you need to provide that. So how can we better design the facades of the building? How can we better orient them? How can we like change the massing so that you have the largest amount of like natural ventilation and passive design and like passive heating and cooling without using energy or without using supplemental energy that you get from all of these different systems. So it starts there. It starts like, what I love about it is that it starts with like the relationship between the interior environment and the exterior environment, and that starts with like the building itself and like the materials that you choose for it and the like even the colors that you paint the building outside, and how reflective it is and how much light you're letting in and the U value of the windows, and there's so many little factors that you can change, how much insulation you add to the building that can help the performance in a like a more physical way or more like passive way than it is for like adding more HVAC or more like mechanical systems that will like use all this electricity or energy to reduce like
That's so cool because it's like fundamentally built into the design from the beginning, not some like afterthought at the end of like, oh, what can we do to ventilate this better? Or
yeah, and I mean the work varies. So like that was an example of what you would do for early stage design. Like if you as a consultant were brought in to like consult early stage design, like okay, massing and orientation are something that you can talk about. But if you're brought in to like something that's already being built, then it's more like, okay, with what we have now and the massing and the orientation and the different room types and like the different requirements for heating and cooling for the different rooms, what kind of systems can we use that are the most efficient?
I see.
So it really depends what part of the project you're brought in at. And then there's also work that's more master planning oriented. So for example, I had a project that I helped work on this summer that was for a university campus, helping them, like doing different workshops to help them determine their goal for 2050 for, like, should they be carbon neutral or should they be, like, reduce their carbon emissions by 80% by 2050, or what is a goal that they can actually achieve to reduce their carbon emissions, and what does that path look like for that university?
Right.
So that was more like bigger picture master planning for like a larger campus instead of like an individual building's energy systems.
Okay. That's
which
awesome.
was also really interesting. And I think that it just goes to show like that you can look at things at such different scales as well. And it's kind of hard to define sustainability. Like, I feel like for each project, we had to kind of redefine what it meant in the context of that project, if that makes sense.
But I think that's really cool, though, because it, like, obviously becoming more sustainable in the future doesn't mean, like, there's this one solution for everyone. Like, it needs to fit the needs of whatever group to actually realistically make some change.
Exactly.
So do you think you'd want to, so obviously Arup does so many different things. Do you want to go into sustainability there or just in your career in general? Do you know?
So it's definitely something that I would love. I think when I think about the future of sustainability, at least my idealistic goal or like what I would want to see is that it's not its own like specific category, but rather it's integrated into everything. Just as like code requirement is integrated into every kind of design, like it's specified more. And that does exist with like ASHRAE standards. And a lot of people like kind of prescribe to that, having sort of energy standards that a building has to perform by. But you do need like the help of sustainability consultants to like be the most up to date with those standards, know what technologies exist, like know what would work best for different kind of projects. But I think that it is something that has to be just like integrated as a standard for every kind of project, especially because climate change is something that's happening, and if we're not going to stop building things, you know, like that's an unrealistic thing to do. But if you're contributing and adding more to the built environment, you're obviously also affecting the natural environment. So helping to like kind of put forth the best sustainability practices in all of these new constructions, and like how can we renovate all of these old buildings that have really bad performance. I think it's something that's critical when we think about like the future of cities.
That's awesome. That's so cool.
I don't think that answered like my career goals,
that's okay.
but because that's something that I'm figuring out for myself too, and like I don't know where in that narrative like my job fits or like my career path fits, but that's kind of the reason why I studied civil engineering in the first place, because I think that the built environment is such a powerful tool for environmental change, social equity. It's like where we live, where we work, where we play, like where human interaction happens, and like how you design it really does impact, I think, society as a whole.
I'm a big believer in that too. So it's really cool to hear about it. And then, so how was it this summer coming from sort of an education that's more like structural engineering based, et cetera? Like you're kind of talking about how your classes are really rooted in that, to sort of branching out and being flexible with like different sustainability solutions.
Yeah. So I think that really comes from the building science emphasis.
Okay.
Because in a studio class is very different from a typical lecture classroom. You have your own personal project, and you can take it in a lot of different directions, and then throughout class you're like working on your project, you're doing your own research, and you have the professor there to guide you, and like you're like, I'm really interested in like using old buildings and adapting them in a new way. And like, of course, you're not the first person that has ever like thought of this concept, and there's actual like a lot of studies about it. There's like a lot of projects you can look at, and the professor's kind of there to guide you to those. Okay, yeah, this is called adaptive reuse. Like that's the term for this concept that you really want to like look at. These adaptive reuse concepts, look at these like architects that use like recycled materials. And through that, I think I kind of leaned towards sustainability, and that was kind of a personal goal that I had in my project development for my studio class. So I think I learned a lot of like mechanical systems and like thinking about energy and thinking about like recycled materials and thinking about circular economy through the context of like my own interest in that and having the space to explore it for a class.
Okay, that makes sense. So it's kind of cool in those classes. You can sort of, there's a baseline, but then you can modify it to sort of your interest.
Yeah,
right?
And I think that depends on the professor.
Okay.
Luckily, we had a professor that loved to allow us to explore our personal interests for the built environment. So there's another girl that loves construction, and she like her whole basis of our project was, like, how can I optimize construction to, like, have the least amount of construction time?
Okay.
So, like, how can I, like, modularize the design a little more so I can, like, prefabricate it and just bring it on site and build it in the quickest time possible. That wasn't something that I focused on in my project, for example, but you could take it in different ways because the prompt is very broad, and, like, basically all he said was build a school. And you had to pick the site, you had to pick, like, your kind of thesis behind the whole project, and it's interesting because there you see people go in different directions. So, like, whether it's constructability, whether it's sustainability, whether it's just, like, learning different architectural concepts, like, or learning different software. Somebody was really into parametric design.
So cool. Oh, my gosh.
So his whole project was, like, okay, I can make this really simple, but I really want to learn all these Grasshopper plugins to, like, learn parametric design, even if it's, like, at a basic level.
Yeah.
So, I don't know, that's just, like, for me, it's such a valuable class because you learn so many things about what other people are interested in as well. And I think you kind of, like, find things that you're passionate about within civil engineering.
Right.
So for me, it led me to sustainability. This was, like, a really long answer
no,
to that question.
It's perfect. So, kind of on that note, obviously Camila is doing really cool things at Arup and in her classes. Camila, what would you say, like, for prospective students who maybe aren't really sure what their major, what they want to study, but they're interested in engineering, like, what sort of student should look into civil engineering and building science?
Definitely. So I think any student that's interested in learning how things come together at a larger scale, like, I think mechanical engineering and civil engineering have a lot of similar foundational, like, physics, statics, mechanics.
Both take all of those
classes. And I think they like, overlap in a lot of ways. But if you're interested more in, like, I don't know, I guess, like, a lot of people that take civil like to be able to see their projects in use and, like, be able to point at a building and be like, I helped create that. Or, like, I don't know, I guess if you're interested in shaping, like, the future of cities, or if you're interested in where people move and how they move and how people live and, like, the places that they live in and the kind of, like, effects that this built environment has on, like, the human experience.
Yeah.
I think civil engineering is great if you're interested in physics, if you're interested in working with, like, natural forces and how to design around those, like, earthquakes or, like, even rising sea levels or problems that you see with the natural world also, like, will affect the built environment. So if you're interested in, like, geology, I think civil engineering is really interesting too because you're building on different soil types, you're building on with different natural forces depending where you are in the world.
I want to be a civil engineer.
If you're interested in construction, I think it's a very social career path as well. Like, you're working with different kinds of people, different grade levels, you know, like, even from the welder to, like, the developer that's bringing in all the money. Like, you work with people from all walks of life. I think that's really interesting. And you should be interested in civil engineering also if, like, that's something that you value. And if you're just interested in how, like, things come together and, like, the nuts and bolts of everything, like, that's also a part of, of civil engineering. I don't know. I think it's also, like, people don't realize how many different career paths come out of it. There's the whole energy sector that needs infrastructure. That's a civil engineer. There's the, like, transportation systems, how everyone navigates their city. That's, like, a civil engineer that can do that. The structural engineer, making sure that everything that we live in is safe to live in and will stand up against all these natural forces. Like, I think there's so many cool things about civil engineering.
I think so too. Well, thank you so much for being here and talking about your major. It's so cool. I wish I knew about building science when I applied. It sounds really incredible, and it's been really cool to watch your experience over the past couple of years.
Thank you.
That was a cool episode, huh?
Yeah. Yeah, it was fun talking to Camila. I think the passion is super evident among a lot of students at Viterbi, but especially with her, she loves building science so much and is really, I think, open-minded about the application of it as well. Like, she's really passionate. In this episode, we talked about sort of how ideally you wouldn't necessarily have a sustainability engineer or something like that. Like, every engineer would be thinking about that. So it was interesting to sort of speak about it in that way as well.
I think it's, what's interesting is I hope more people listen to this episode specifically related to civil engineering, because I think it often gets overlooked from like a high school perspective as something that somebody wants to do. I think a lot of people inaccurately refer to civil engineering as old technology and something that we don't need, whether that's building science or sustainability or construction management or water resources, all of our different programs in the areas. It's one of the most needed elements for society, this idea of infrastructure and rebuilding our infrastructure and doing it in smart ways that's collaborative with other types of engineering disciplines. When people talk about a smart grid and they think about electrical engineering and power resources, that involves civil engineers. And we have to be able to get that word out and let people know that civil engineering is incredibly important.
Absolutely. And I think too, we touched on this in the episode, but like the built environment is so fundamental to the way we interact. It facilitates everything. I'm a big believer in the power of, what that means for us. And I think for building science in particular, I wish I would have heard this podcast as a high school senior, because it's such a cool major, because you get to take architecture studio classes. Yeah. And I think it really powerfully combines some of the sort of technical aspects of engineering that everyone who wants to study engineering is drawn to, with something that's like genuinely creative and you can genuinely sort of explore.
Right. So it's a perfect mix of that design aspect and the technical aspect.
Totally.
And it's an engineering degree and different from an architecture degree. Architecture degrees here at USC are 5-year programs. Yeah. Design focused, more like an art school. And our engineering degree program in civil engineering and building science is a 4-year civil engineering degree with architecture courses built in throughout. So that is, I think, a good transition to what we're doing now. In this like backhand, we have to come up with the name of this. Is this our exit conversation? Is this our ending? Is this our summary? I don't know. This is the end. What we used to do as an intro. Yeah. It's just talk and catch up and also do some updates from around campus. But how are your classes going? Are you 2 weeks in now?
Yeah, this is the end of our second week of school. Yeah, pretty well. It's I have a pretty heavy course load this semester.
I wish people could see your face when you said heavy.
Yeah. I enjoy pushing myself on that one. I'm taking an insane number of classes, but it's actually been surprisingly okay so far. Right. I think the classes I'm taking this year are really challenging but really interesting. So it's less sort of problem set focused and
well, MECOP's in it, right?
Yeah.
I mean, we talked about it last week.
We did.
A little bit, didn't we? Did we bring it up?
Maybe. Yeah. So for those of you who don't know,
maybe it was off the mic.
Maybe. There's a course that mechanical engineers, aerospace engineers, astronautical engineers take junior year called MECOptronics, which is a word of USC's crafting.
Mechanics, optics, electronics.
Exactly, yeah. So it's a really cool course because it's awesome to learn about the combination between mechanical engineering, optics, and electrical engineering, because I think often in industry, that's really where you are sitting as a mechanical engineer. And it's lab-based, so it's super hands-on, but it is kind of notorious because it's really challenging, but
it's a lot of work.
Yeah, I'm excited though because I like hands-on sort of classes, so I'm excited to have that lab-based class, but a little nervous, but that's okay.
Yeah, I think that most of the nerves and the feeling are about how others talk about it.
Yeah, totally.
And then when you get through it just fine. but you have this cast of like, oh my God, as you go through it. Because granted, it's a lot of work, but you all will do it. You'll all be fine.
Yeah, I agree. I think a lot of courses are like that. And I think in general, at times engineering can be like that as well, where a lot of the stress kind of just comes from people talking about how stressed out they are.
Exactly.
Which is so annoying. Don't do that. But I think there are certain courses that are just genuinely really, really challenging and stressful, and this is one of them. Like
Absolutely, totally.
It's not
easy.
It's not like an idea. It's actually just really hard, but that's okay. There's some. It'll be good.
Well, good. Well, I'm glad that that's all working out for you, and I know that classes will get hard. And also, second week it doesn't get too hard yet, but it's coming.
Yeah, definitely. I mean, we already had assignments due this week. I think. You sort of hear this thing at the end of high school that's like, oh, like still this week, or I don't know, just kind of that you have a lot less homework in college,
right.
which has never been true for me.
Right.
It's always kind of jumping in, but I think a lot of the busyness of the first 2 weeks is just the excitement of being back on campus and seeing your friends and all of that too, which is fun. So,
but yeah, sometimes I tell our engineering students that you don't have less homework. It's not true.
More.
But other college students do, and it always kind of reflects itself in the beginning couple weeks.
Yeah.
Because another major, it's usually how the class is structured. An engineering class or a technical math science class is basically week by week of problem sets. Mm-hmm. You know, it's learn, problem set, and then evaluate, like measure, right? So you got your like some sort of either weekly exam or more frequent midterm exam. And you do that kind of consistently throughout. And by the end, sometimes it's not cumulative. Sometimes it is, but even if it is, you've been doing it so regularly, it's like a workout routine.
Yeah.
That your final is just kind of a slightly ramped up workout routine, but you've been prepping for it the whole time. And that's only different than, let's say, an English major that is read these books by the end of the semester. And then their exam or their final paper is this like giant snowball effect of giant work that they have to do, and it's slightly different. Now, granted, you will have final projects and classes that are a lot of work, but typically it's like you've been working out up to that point to get it right. So it's a little bit different, and sometimes people at this point are like, why do I have all this work when no one else does? And it's just, you'll get there. It all catches up.
Yeah, I think, too, a cool part of being at USC is also just understanding that yeah, well, you may have a lot of problem sets and things like that in engineering, in our art schools and in our humanities schools here too. Like, kids are doing incredible work that they're working really hard on too. So I've never really felt like on campus, like, oh, I have so much work and no one else does. It's just different. It's a different kind of work.
Yeah.
And I think that's one of the most exciting parts of being here is sort of seeing people, seeing the grind in multiple areas and like seeing the output. I mean, in Kaufman to go to one of their final projects or something like that, it's incredible.
Right.
So, yeah, it's cool to just see people who have that drive in this field that they're passionate about, even if it's not engineering.
Cool. A couple updates as far as for those of you that are prospective students and that are looking to possibly apply for the Viterbi School of Engineering. Just a reminder, the application is live now. You can go to either admission.usc.edu and learn about it, or viterbiadmission.usc.edu and learn about our application process. And then we're a Common App school, so you can list USC as a school that you're applying to and start working on the application. It is due by December 1st. So December 1st is the scholarship application deadline. There is no scholarship application, but you just need to get your application in by December 1st in order to be considered for our competitive merit-based scholarships. And January 15th is the final deadline. And that's, I always recommend, there's no reason not to hit the December 1st deadline. We have a number of events that will be going on starting next weekend. And so starting September 14th and 15th, starting September 13th, we will have staff literally around the world, starting in New Delhi, India. We will have staff there for the admission office and for the Viterbi School to talk about what's happening in admission and help you understand our programs. We'll also that weekend be in the Bay Area, one program in Santa Clara on Saturday and a program in Oakland on Sunday. Also on Sunday, the university will be holding events concurrently in Mumbai, India, and also in Hong Kong. And then we move into the next weeks where we'll be continuing into Beijing, Shanghai, Taipei, and exotic locales such as Phoenix, San Diego, and your hometown, Denver.
Ooh.
So those are the next 2 weeks that are coming up here. Me personally, I will be in Shanghai and Taipei. So if you are in those areas, I look forward to seeing you in Shanghai on September 19th and in Taipei on September 21st. If you're in the Bay Area, you're going to see our colleagues Michael Cox and Rebecca Bider, and they'll be in the Bay Area with you. And New Delhi, Mumbai, you will see our Associate Dean of Undergraduate Students, Matthew O'Prey, and he will be present at those programs. So we'll check into you from time to time, week to week, as we have these different events. But if you ever need anything related to admission, please go to viterbiadmission.usc.edu and look at the application deadlines and information, and we have a lot of helpful tips there on how to get through this application process. If you're looking to visit campus, there's a visit link right there. You can come and participate in our Meet USC program. And if you want to register for one of these off-campus events, that is also on our visit link. So lots of things for you to do there. If you ever need anything, please reach out to us. Any updates on your end?
No, an exciting time. It sounds like
Recruiting season in full gear. We're going to get on planes. I'm gone. Like I'm not going to be in the office next week.
Oh my goodness.
Like I'll be here next week, and then I'm gone for a week and a half. I'll be back for 1 day, gone for 4 more days, and then I'm back. So I really the whole month of September, I'm barely here.
Wow. Well, an exciting time for both Paul and high school seniors.
One of those is true. All right. Well, let's get out of the way and get out of here, and we'll see you next time.
Thanks.